These next three problems, we will look at completing the square when a is larger than 1. So let's take the first one. You get 8x squared plus 16x. I'm going to add the 42 over. And since a is not 1, I would like to make the coefficient of x squared 1. So I'm going to factor out 8, which will leave me with x squared plus 2x, making room to complete the square. So I'm going to, here's my b value, 2. So I'm going to take half of 2, which is 1. When I square 1, I get 1. So what have I added to the left side? I've added 8 times 1, which is 8. So I want to add that over here. So I get 50, and I get 8 times x. Since I've created a perfect square trinomial, it's going to be x plus, because of the sign. Square root of 1 is 1, or half of 2 is 1. And so that is what I'm going to rewrite that, because I'm going to solve this in just a moment to find my solutions. So here I want to subtract the 50 so I can get to my vertex form. So my vertex would be -1, -50. And now solve for my solutions. What I want to do is I want to divide by 8 on both sides, because I want this a value to be 1. So x plus 1. And I'm also trying to get, I need access to that x. So I need to peel back each operation. Since 8 is multiplied by this expression, I want to divide by 8. So 50/8 is the same as 25/4. Now I've got a squared term, so I'm going to square root both sides, and that'll give me x plus 1 equals, and then the square root of 25 and the square root of 4 would be 5/2, and x plus 1 equals -5/2. Well, if I subtract 1, that's subtracting 2/2, so that's going to give me x equal 3/2, or x equal 1.5. And then if I subtract 2/2 here, I'm going to get x equal -7/2, not fifths. But x equal -7/2, and that's the same as -3.5. So the solutions would be -3.5, 0, or -7/2, 0, if you want to work with the fractions. And here it would be 1.5, 0, or -3/2, 0, if you're working with the fractions. So there would be your solutions. Second one, we've got 2x squared minus 8x. I'm going to subtract the 6. I need this to be a 1, so I want to factor out 2. So I'm going to get x squared minus 4x. And then I want to take half of -4, which is 2. And when I square 2, I get 4. But what am I adding to the right side? I added 4, but it's 2 times 4, so I need to add 8. So that's going to give me 2. So I'm going to get 2 times the quantity of x squared minus, well, I already have my perfect square trinomial, so I'm not going to write that again. I've got 2 times x minus 2 quantity square. So when I go to write my vertex, I've got 2 times the quantity of x minus 2 quantity square. I'm going to subtract my 2. And so my vertex would be 2, -2. So over here, I've got the 2 times the quantity of x minus 2 squared equals 2. And I want to solve for x, so I'm going to divide by 2. And that's going to give me x minus 2 quantity square equal 1. And then if I take the square root of both sides, I get x minus 2 equal 1, and x minus 2 equal negative 1. So x would equal 3, so it would be 3 comma 0, and x would equal 1 or 1 comma 0. So those would be the solutions. And final, I've got 6x squared minus 18x minus 24 equals 0. So I'm going to add the 24. So I get 6x squared minus 18x equals 24. And I want to factor the 6. So I'm going to get x squared minus 3x is equal to 24. And in this case, this b value has been the first one where it's been odd. So what we're going to do is we're going to take half of the b value, which would be negative 3/2, and we're going to square it, and that would give us 9/4. So that's what I'm going to add here is 9/4. Or I'm going to add 6 times 9/4, and 6 times 9/4 would be 54/4. And both 54 and 4 can be divisible by 2, so that would be 27 halves that I'm going to add to this side. So I'm going to get 6, open parenthesis, x squared. Well, I have that already created, so I'm not going to rewrite it. It's going to be x minus, and then what's half of 3? That would be 3/2. Or if we said what's the square root of 9/4, that would be 3/2 as well, and that quantity square. And then what I have is, if I want to add these together, I have a mixed number. So I would have 24 is the same as 48/2, and 48/2 plus 27/2 would be 75/2. So if I want to now solve this, I want to divide by 6 or multiply by 1/6. And I'm going to get x minus 3/2 squared equals 75/12. And both 75/12 are both divisible by 3, so that would give me 25/4. And then I want access to the x, so I'm going to have to square root both sides. And that's going to give me x minus 3/2 equals square root of 25/4 would be 5/2. And then x minus 3/2 equal to negative 5/2. So when I add 3/2 over here, I'm going to get 8/2 or 4. So 4, 0 would be one solution. And when you add 3/2 over here, you're going to get 2/2, negative 2/2, and that would be negative 1. And so negative 1 comma 0 would be the solutions for that quadratic when completing the square.